VR Unity and Unreal Project Development Course. Video 8. Terrain Creation in Unity. Welcome to JMPVR, my YouTube channel. It is a pleasure for me to be here again today, with all of you. Your invaluable help is very important, so that we can continue developing support videos for new independent developers. Please, do not forget to subscribe to our channel, and support us on Patreon. As you can see, the first part of this video is identical to the previous video in terms of obtaining the digital terrain model in Google Earth. However, we have decided to repeat it in this video, so that you can have the complete sequence of the process. Okay, let's start by reviewing some basic concepts. Whatever VR project we want to develop, it inexorably needs an environment in which to develop our action. This environment can range from a simple room to a large landscape area. The object of today's video is to analyze and create a terrain in the easiest and most realistic way possible. Both Unity and Unreal have tools to generate terrain. However, neither Unity nor Unreal are appropriate applications for the generation of a realistic terrain, and require a very high artistic skill to achieve good results. Unreal, as we will see, has greater power when it comes to generating terrain. However, the generation process is more complex than in Unity. On the other hand, both in Unity and Unreal, we can use the terrain generation tools to edit a terrain generated by an external application to these VR engines. Then the first conclusion that we obtain is that we must generate our terrain with a specific terrain generation application, and later, once imported into Unity or Unreal, proceed to edit it if necessary with his own tools. Undoubtedly, at least today, Google Earth, due to the stability and quality of the altimetry data, is one of the best tools for obtaining digital terrain. Another important point is to obtain a suitable location for our VR project. For example, if our VR game takes place in a city, we must select a location area corresponding to a city in Google Earth. If on the other side, our VR game is developed in a forest, we must locate in Google Earth an area with characteristics similar to those desired. Let's talk about the process that we are going to follow through the next workflow diagram. Let's see the steps we are going to follow to obtain our land. First, we will select a location in Google Earth. Once the desired location is obtained, we open that location in Blender GIS. If you don't have the add-on installed, you can get it from GitHub. After that, we import the altimetry data into Blender. Next, we apply the necessary modifications to the terrain model obtained, in order to be able to implement our urbanization area, where our VR game takes place, such as platforms, high roads, paths, etc. Once the final model is obtained, we will generate a 3D mesh in FBX format. As last step. Once this process is finished, we will open a new project in Unity. Next, we will import our terrain model through 3D mesh object. Finally, we will convert it in terrain in Unity through the Object-to-Terrain application, that you can also get it on GitHub. Well, once explained the process of obtaining our land, we are going to develop it, step by step, so that you can follow it, in a clear and simple way. Well, as we have explained in the previous section, we need to search for a location in Google Earth, according to the purpose of our VR game. In our case, our VR game The Ramson House needs exteriors corresponding to a mountainous area of medium altitude, since our mansion is located near a road, in the middle of a forest. Once we have established the type of location we want to use, we search for it in Google Earth. In our case, we have located it in Spain, near the municipality of San Lorenzo de El Escorial. And within that municipality, we have chosen the mountainous area adjacent to said municipality. So let's get started. We open Google Earth, and look for the selected zone. On the selected zone is located, we make a screenshot, and save the file in image format. This image will serve us exclusively as a reference image. Let's move to Blender GIS add-on. First, we check that we have the Blender GIS add-on installed in Blender. Remember, if you don't have it, download it on GitHub, and install it in Blender. To do this, we open Blender, first we select Edit, and then we select the option Preferences. Next in the new pop-up screen, we select Install. We look for the file downloaded, in zip format from the add-on, and select it. Next, the add-on 3D view, Blender GIS will appear in the add-ons list of Blender, and we make sure that the corresponding box is checked. After that, a new GIS option will appear in the Blender menu. We open Blender and we select the option GIS. In the new drop-down window that appears, we select the option Web Geodata. A new menu will appear next, in which we will select the option Base Map. We leave the default options that Blender GIS offers us, and we select OK. As we see on the screen, a world map of Google Earth appears. We press the letter G and a new screen appears, in which we can enter the municipality of the desired location. Next, we navigate through the area until we get an image similar to the one previously obtained in Google Earth. Once the image of the desired area has been adjusted on our screen, we press the letter E. Blender will cut out the external image that we can see on the screen, obtaining a cutout of the Google Earth digital model. We can check now, by navigating on the terrain obtained, that our terrain model is flat, and does not have any altimetry at the moment. The time has come, in order to incorporate the altimetry data into our digital terrain model. To do this, let's select again the GIS option, and the Web Geodata option. This time, in the new drop-down window, we select the option Get Elevation, SRTM, and we leave the options that Blender GIS offers us by default. Next, we press OK. After a few minutes, we will observe that our digital terrain model has acquired the altimetry data. We select our digital terrain model, and we select Apply Transform to each of the modifiers of our model, and we adjust the size and vertical scale to suit our needs. Now, we have a digital mesh of a real terrain of our desired localization. The time has come, in order to incorporate our platforms into the digital terrain model previously obtained. In our case, we will need an excavation platform in order to accommodate the basement of the mansion, a platform for the interior urbanization of the mansion plot, and the platforms of the surrounding roads, and finally the platform of the access road to our mansion. So, we proceed to place the platforms models in Blender over our digital terrain model. Once the two models are located, we proceed to edit vertex, edges and faces of the two models, until we obtain the combined digital model. Well, keep in mind an important fact, that it is the dimensions of our final terrain model. The dimensions in our case, of the digital model are 2000 meters wide, 2000 meters long and 264 meters high. We will need these values later. Now we proceed to export our model in STL format. In this way, any error of duplication of vertices in the mesh of our model, it will be eliminated. And we proceed to import the generated file in STL format, into a new Blender file. Now, we proceed to import the terrain model file in STL format, and check that all the faces of the mesh have the correct orientation. To do this, we will select the face orientation option in Blender. If we detect that any face does not have the proper orientation, we will proceed to select it, and recalculate the normals, by simultaneously pressing the Shift+N keys. Once We have verified that the model is coherent, and all the faces are correctly oriented. We will export our terrain mesh in FBX format. In this way we can already incorporate our terrain in Unity as a 3D object. However, Unity will not understand it as terrain, and we will need to perform a conversion from 3D mesh to terrain object within Unity. The time has come to create a new project in Unity, that we will call as example terrain. Remember that you can use any name for your project. To do this we will create our terrain project in Unity Hub, selecting the 3D template. And we will wait until the project is loaded. First of all, we create a new directory that we call terrain. In this directory we copy the script object to terrain. Remember, if you don't have this script in your assets, you can get it on GitHub. Now, we copy in this same directory terrain, the terrain model previously exported in FBX format. Let's start the process of converting our 3D mesh to terrain in Unity. First, we include our 3D mesh model in the scene. Now, our 3D mesh model for Unity is a simple 3D object. Next, we select our 3D object from the scene, and in the Unity Editor menu, we select the option Terrain. In the pop-up menu, we select the option Object to Terrain. A new pop-up window will appear, in which we will select the option Create Terrain, leaving the rest of the parameters unchanged. Automatically, Unity generates a terrain copy of our 3D mesh. However, we are only going to use this terrain model to obtain a raw type file. So, we select the generated terrain in our scene, and we look for the value of the dimensions of the generated terrain, checking that they coincide with the dimensions of our 3D mesh model. That is, 2000 meters wide, 2000 meters long and 263.8 meters high. We are going to need these values below. We select the option Export Raw, and the option Export, and we save the file in Terrain directory. We already have all the elements to generate our terrain. We create in our scene a new terrain in Unity, and we give it the real dimensions of our terrain. That is, in our case, 2000 meters wide, 2000 meters long and 263.8 meters high. And finally, we select the option Import Raw in our new terrain. We can now erase the rest of the generated models, and stay exclusively with our new terrain, to which we will apply the textures we want. Conclusions. As you will have observed, the process of obtaining a realistic terrain from a selected location, and its implementation in Unity, it is very simple, although it involves a shorter process of obtaining the model than in Unreal. I advise you to practice this method until you have mastered it completely. And so far the 8th video of the VR Unity and Unreal project development course. Do not forget to subscribe to our channel, and support us on Patreon, so that we can continue to help you, by providing you with the necessary knowledge for the development of your VR game. I hope this video has been to your liking. I wait for you in the next video of the course. Thank you for your support and attention.